This tutorial video will illustrate the creation and customization of bar charts in KIWI Explorer. I will first illustrate how you can select one among the three different styles of bar charts available in KIWI Explorer. Then how you can select the variables displayed in the bar charts. Finally, for one of the bar chart design, you will have the ability to transform a continuous variable into a categorical variable using various binning options, which I will try to illustrate here. Let's now switch to the application. I have opened KIWI Explorer for two datasets. The first one is called meansd.csv. It is a very small data file as shown in this Excel window. Some experimental endpoint was measured in 9 different conditions based upon the concentration and groups. The measurements are documented in the result variable. Group C is just the character version of the group variable. The second dataset is called subset_demo.csv. This is a population PK data file that we have used in other tutorials. This page is shown side by side with the profile manager, which I will use to illustrate the settings you need to define to achieve the designs described in those different profiles. So I will show the first profile, which illustrates the first type of bar chart that you can create. This bar chart is so using the meansd.csv, and it's showing the content of the result variable against the content of the concentration variable. So you remember that our result variable was collected in 9 different conditions for 3 concentrations. So we have 3 measurements for each concentration, and those measurements are added. The number at the top represents the sum of those 3 bars. So to achieve that design, you need to go to the basic settings panel, and no, I just want to view that panel. You need to set the bar chart type field to Y versus X, so that indicates that you want to display the value of a Y variable versus an X variable, or a Y-axis variable versus an X-axis variable. The X-axis variable field is the next field, and you need to provide a selection. The next field relates to the other design of bar chart. You need to go to the last field to provide the Y-axis variable. So this is how you define this, or you achieve this particular design. In most cases, if you will have a single measurement or value of your Y-axis variable per group or per level of your X-axis variable. In our case, we had 3 that were obtained for 3 different groups. So I just created another version of the same bar chart in which a grouping variable was used, and that was achieved by using the stratification panel. In this case, I set the group variable as the grouping variable, and the result was that each box is now colored by differently for each of those groups. At this point, I would like to mention that information about stratification has been provided in a separate tutorial dedicated to stratification functionality. The functionalities are strictly similar in bar chart to what is available in the other plot EDA categories, so we will not describe those functionality in this particular tutorial. I invite you to watch this separate video on stratification strategies. And I will move on now to the second design of bar chart, and for that I will switch to the subset_demo.csv. The second bar chart design is a design in which you use a single x-axis variable, and the y-axis variable is a count of records associated with each value of this x-axis variable. The number of count is automatically calculated by KIWI Explorer. So in this particular situation, you really need to think about your data subset and what would the second bar chart design is a design relying upon a single variable for your x-axis, and the y-axis variable represent the count of records associated with each unique value of your x-axis variable. So in this case we had 32 records for this particular level of study C. So in this design you really need to think about the intention and what this count represent. And for that you also need to think about your data subset. For this particular bar chart, my intention was to represent the number of subjects per study in my data set. So these 32, 80, and 48 represent how many subjects were included in each study. And for that I had to define a data subset and set this field, this skipped field, to first record per subject. I would like to also point out that data subset functionalities have been described in a separate tutorial, which I also invite you to watch to learn more about how you can use those different fields to impact the data subset using your bar chart. Beyond selecting the data subset, I had to select a specific design in the basic setting field, and I set the bar chart type to frequency by x value. When you set this bar chart type to this particular selection, you really only need to select an x-axis variable and let the y-axis variable to default. If the x-axis variable is categorical, like it was the case here, or if it's a continuous variable that you have formatted using the configure format collection, and set a format collection here, so transforming your let's say a numerical variable of study 1, 2, 3 into their formatted values. So in that case, where you can consider your x-axis variable as categorical, you really don't need to use any other settings here. The situation is a little bit more complex when you want to represent the counts or frequencies of records associated with specific intervals of a continuous x-axis variable. So this is what is shown in this next design, or next profile. The x-axis variable was age, which is continuous, but we obtained counts of subjects within specific intervals. In this case, the intervals are represented by the midpoint of the intervals, as shown in this footnote. So to achieve that design, you need to go to the basic settings and you need to provide a little bit more information here. So I still have my bar chart type set to frequency by X values. The X-axis variable is now H, which is continuous. The next thing you have to do is to say, I want to bin my X-axis variable by interval. The next field that I did not have to set because midpoint is the default, but you can define whether your intervals are displayed or reported using the midpoint or displaying the full interval. In this case I use the interval, the midpoint, sorry. So that's what you get when you define the midpoint. If you want to display the same plot with the actual intervals and the boundary of the intervals, you need to set the interval display as field to interval. I'm going to mention at this point one advanced settings. Sometimes when you have many intervals, the text could overlap if this text was displayed horizontally. So to achieve this little slant or slight slant, you need to go to the Advanced Settings panel and define the X-axis tick marks rotation to some positive number. In this case was 30 degrees. So yes, this number is a number in degrees. Another advanced settings that you need to set to a non-default value is this first field. The individual specific scale needs to be set to free. It is not necessarily apparent, the need for this field is not necessarily apparent when you have a single panel, but when you have multiple panels or conditioning, every panel needs to have its own set of range for both X-axis and Y-axis. So this is a must. So you have additional settings that you can use to define how the bins are obtained. In this example, I use the default automated detection of bins, but there are various fields that you can use to either provide the custom sets of boundaries. So instead of letting R or KIWI decide what are the most appropriate boundaries, you could say I want to have intervals between 10, 20, 30, 40, 50, 60, so basically by increment of 10, and KIWI will apply those values. So you need to enter these values in the custom interval limits, and each boundaries or each limit will have to be separated by a comma. The next field is actually illustrated in the next profile. In this one, I set the number of intervals to 5. So I said, instead of using 9 or 10 intervals like in the previous profile, I said no, I just want 5. And you can set that here. You could define whether the intervals are of equal width or equal number or frequencies. That would be if you set this field to false. You can also define a specific width. So coming back to my example of I want to use a bin of age that have like a 10-year span, you could set this custom interval width to 10. The last field or customization that you can provide is how the intervals are defined. The default is to use left open intervals, so intervals that would exclude the beginning boundary, except for the very first one. You could use right open intervals, in which case the upper limit of the intervals would be excluded for all intervals except the last one. So this is an overview of all the options that you have for the second design of bar chart, the frequency by X value. Before switching to the last design, I want to quickly use an intermediate step for the explanation that I'm going to make. Still using a frequency by X value. In this case, I have displayed the number of records per subject. So I've selected my ID variable as my x-axis variable. There are a lot of subjects here, and their subject ID is fairly long, so everything pretty much overlaps and you have a lot of bars. I changed my data subset to oops, I didn't really want to do that, but all the records in a subset that contain only the so the sample equal 1 was a way to indicate sample records in my population analysis dataset, and I only looked at the study 1. There were 3 studies in this dataset, but I would have been a little bit too busy. So here I have a bar chart summarizing the number of sample record for each subject in my dataset. So I had numbers that ranged between 18 and 23. There is a frequent plot in exploratory data analysis of population analysis, which is the number of subjects that provide a certain count of records. That gives you an idea about how many subjects provided a certain amount of information. And the way you would do that outside of KIWI is you would first process the data as it was done here and get the number of records for each subject. Then for each unique count, for example 22, you would count the number of subjects that produced this number of counts. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 for this particular subset. And you would do that operation over and over again for each unique values. And then you would process that count into a new bar chart. So in KIWI you don't really have to do that heavy lifting. You can use a particular design, which is the last one, and get this count of subject that provide a certain amount of samples or a certain amount of records. So here I have the entire data set with my 3 studies. Each study is shown with a different color, and this bar chart reports the number of subjects that provided 2 records, 3 records. So those low counts were in my 3rd study. Then there are 2 subjects providing 16 records, and so on. So the way you achieve this design is by going again to the basic settings panel and selecting the last bar chart type, which is frequency by count of unique X value. Typically, you would select some kind of subject identifier variable, and the rest of the field could be left to default. You really only need to set this field and define the variable that you want to process according to this design. In this particular case, I set my subset to the sample equal 1, so my sample records, I use all the records within this subset, and I also use a study as grouping variable to get my my bars colored by study. I want to mention one last thing before concluding this presentation. Each bar chart creating in KIWI Explore is associated with a little text-based report that you can open by double-clicking anywhere inside a bar chart. This opens a little window showing this report. The report provides additional information for each category in your bar chart. So these are each bar essentially. The first column in this little table is the total associated with each category, so that's those totals are exactly the same as the one represented above each bars. The next column is a cumulative total, so it's this count minus all the counts from the previous bars, and the last number will give you the total number of records included in all the bars. The next column is a percentage column associated with each category. So for the first category, the percentage is this total divided by the grand total multiplied by 100. And the last column is a cumulative percentage. These numbers allow you to process and analyze your bar chart a little bit differently. For example, you could say that 30% of your population or your subject provided 20 records or more. So it allows you to interpret your data in a different way. So with that, this concludes our presentation of the functionality allowing you to create bar charts in KIWI Explorer. Thank you.